Hello everyone, we are continuing to master logarithmic topic for AP Calc BC exam. The first part was about definition and formulas, and the second video would be about practice test problems and their solutions from the real exam. So let's see our first problem. We have z expression and we need to prove that it's equal to minus log a4. You can see that everywhere there is a in the base. So let's solve it. First of all, what we can see? We can see that here 1 divided by 2 in the multiplied. So we can just have that number in the degree by power property. So it would be equal to logarithm a in the square root of 256. And because we know that the square root of 256 is equal to 16, we can write it as 16. So it would be 16. And we would have logarithm a of 36 plus and minus 2 times logarithm a 38. So then we have that there is similar base, same base. So we can use property of multiplying. So this thing would be equal to logarithm a 36 times 16 minus, because here we have multiplied by 2, we can bring the 2 into the power. It would be minus log a 36 in the power of 2. And that thing, because you have again the exact same base, we can use property of quotient. So that thing would be equal to logarithm a 36 times 16 divided by 48 in the square. And because on the AP calculus you would have calculator, you can calculate that thing would be equal to logarithm a in the base 1 divided by 4, which would be equal to logarithm a 4 but minus, because if you divide it by 1, we can plug that value into minus. So our second problem, we need to find the value of that expression. Again, we have the same base everywhere, and we have plus, so we can use like multiplying property. That thing would be equal to log 2 in the base 5 multiplied by 1 times 0.6. That would be equal to log 2 in the base and 8. And that thing is obvious to see, that would be equal to 3. So our answer is 3. So next two problems. The first one, we have x is equal to 2 in the power of p and y is equal to 4 in the power of q. And we need to prove that z expression is equal to z. So because we can just rewrite that expression as log 2 in the power of 3 times 2 in the power of q, 4 in the power of q. And because we would have 4 in the power of q, we can rewrite it as 2 but in the power of 2k. And because we know that because we have log 2 here, we know that that thing would be equal to 3p plus 2q, just by definition. Because we need to find the number in which, if we plug it in the degree 2, it would give us that value. And because that value is equal to 2 in the power of 3p plus 2k, we know that logarithm would be equal to that number. So the next problem, we have two statements. The first statement, we have again the same base, and we have minus. So if we use quotient property, we would know that that thing is equal to log 2 3 divided by 24, which equal to minus 3. And for the statement B, we know that here we have 1 divided by 2, 1 divided by a, sorry, and we have z multiplying by 4. So because z thing is equal to a minus in the degree 1, we can just plug z4 into z degree by property of power, and we would have that thing is equal to logarithm a in the base a squared minus logarithm a in the base, and a is power of minus 4. And that thing is equal to, because you have that minus and you have the same base, that thing would be equal to log a in the base a squared divided by a minus 4. That would be logarithm a in the base a in the power of 6, and that would be equal to 6. It's obvious. So if you liked the video and want to see another topics from the AP Calculus, please share your comments and put likes for that video.